Dear friends, Maths Aspirants groups organizes several online problem solving sessions to help the students who prepare for different national level competitive examinations. As a part of that series, today we have a session on systems of linear equations, and we have Miss Rupali Khurana is with us to engage the session. Miss Rupali did her B.Sc honors and M.Sc from Maharshi Dayanand University, Rohtak, Haryana, and she is currently pursuing PhD there. I welcome everyone to this program. Welcome, Rupali.
First of all, thank you, sir, for giving me such an opportunity to deliver a lecture in your platform. We will start from the system of linear equation, and if time permits, then we will move towards the rank nullity and rank nullity theorem. We will start from the system of linear equation. Firstly, a system of linear equation is a list of linear equation having same number of unknowns. In particular, we can say that a system of M linear equation, say L1, L2, and so on Lm in n unknowns. That is, say x1, x2, and so on xn, which can be put in the standard form. Let us take a11 x1 plus a12 x2 up to so on a1m xm is equals to b1, a21 x1, a22 x2 up to so on a2 and xn is equals to b2 and so on. These are the system of linear equation. Now this system can also be written as ax is equals to b. Here a is the coefficient matrix, that is a11, a12 and so on a1n, a21, a22 and so on a2n, up to so on an1, an2 and so on ann. This is known as the coefficient matrix. Here B is the column vector b1, b2 and so on bn. Now we have the two types of system. First one is the homogeneous system and second one is the non-homogeneous system. For the homogeneous part, we have B is equals to 0. Then the system reduces to ax is equals to 0. And for the case of homogeneous system of linear equation, the solution is always exists. So we can say that the system of homogeneous system equation is always consistent. Now we have two case arises. Either it have unique solution or it will have infinite many solution. For unique solution, we have determinant of A is not equals to 0. Or we can say that rank of A is equals to number of columns or the number of variables. If the determinant of A is equals to 0 or the rank of A is less than the number of column or the number of variables, we can say that the system of homogeneous equation has a non-trivial solution or the infinite many solution. The other case is the non-homogeneous case. In this case, the B is not equals to 0. Now here three cases arises. One is unique solution, second is no solution, and third is infinite many solution. For unique solution, we have rank of A is equals to rank of A augment B is equals to number of unknowns. We will discuss what is A augment B. Here we can say that A augment B is equals to A11, A12 and so on A1M, B1, A21, A22 and so on A2N, A2M, B2 and up to so on. This is the augment matrix. If the rank of A is equals to rank of A augment B and is equals to number of columns, or we can say that the number of variable, then the solution is unique. If the rank of A is not equals to the rank of A augment B, then the solution then there exists no solution. If rank of A is equals to rank of A augment B and it is less than number of columns, or we can say that less than number of variable, then the solution is infinite. Now we will discuss some easy and some moderate level question based on these results. The first one is the system 213, 301, 125 ABC is equals to 542, which can be written as AX is equals to B. Firstly, we will write the augmented matrix of this system. 2, 1, 3, 3, 0, 1, 1, 2 and 5, 5 minus 4 and 14. Now, firstly, we will interchange the row 1 with the row 3. We get 1, 2, 5, 2, 1, 3. 1 second. Uh, it's 1, 2, 5 and 3, 0, 1 and 2, 1 and 3. Now, firstly, we will apply R2 to R2 minus 3R1 and then R3 to R3 minus 2R2. And R2 to R2 minus 3 times of R1. Then what we get? 1, 2, 5, 14 and 0, minus 6, minus 14 and minus 46. And third row becomes 0, minus 3, minus 7 and minus 23. As you can see that R2 is equals to 2 times of R3. Then from here we can see that rank of A reduces to 2 and rank of A augmented B, which is also reduces to 2, and it is less than the number of unknowns. Number of unknown is 3. From here we can see that rank of A is equals to rank of A augment B is equals to 2, and which is less than equal to 3. Here the solution is infinite. Now let us consider another question. Now firstly we will write the augmented matrix. That is 1, 1, 5, 1, 2, M, 1, 2, 4, and K. Firstly, we will reduce this system into the row echelon form. Then what we will do? R2 to R2 minus R1 and R3 to R3 minus R1. We will get 1, 1, 5, 0, 1, M minus 5 and 2, 0, 1, minus 1, K minus 3. Then we will do R3 to R3 minus R2. And we get 1, 1, 5 and 3, 0, 1, M minus 5, 2, 0, 0 and minus M plus 4. Ratio K minus 5. Now let us consider the first option. First option says that M is not equals to 4. From here, if M is not equals to 4, then rank of A becomes 3. If rank of A becomes 3, then rank for any values of K, rank of A equals to rank of A augment B, and which is equals to 3. If M is not equals to 4, then the coefficient matrix, rank of the coefficient matrix is 3, and rank of A augment B will also becomes 3 for any values of K. From here, we can see that the system is consistent. Therefore, option number A is correct. Now let us take the option number 2. K is not equals to 5. Here you can see that if the value of K is not equals to 5, then this position is always non-zero. And if you take M is equals to 4, then rank of A becomes 2 and rank of A augment B becomes 3, which is the case of the no solution. If the K is not equals to 5, then this position is non-zero. And M is equals to 4, rank of A is equals to becomes 2 and rank of A augment B becomes 3, which is the case of the no solution. Now take an option number 3, M is equals to 4. Here you can see that if M is equals to 4, then rank of A reduces to 2, and if value of K is not equals to 5, then system is always a no solution. And now see the option number D. If K is equals to 5, if K is equals to 5, then this position becomes 0. Now for any value of M, we get 1, 1, 5, 0, 1, M minus 5, 0, 0, minus M plus 4, and this will become 0. Now for any value of M, this system will always have a solution. Either it is unique or it is infinite. Now move to the next question. Let us consider the system of linear equation x plus y plus t is equals to 4, 2x minus 4t is equals to 7, x plus y plus z is equals to 5, and x minus 3y minus z minus 10t is equals to lambda, where x, y, z, and t are the variable and lambda is a constant. Then which of the following is true? For this, let us write the augmented matrix. Coefficient of x, coefficient of y, coefficient of z is not present. Therefore, we will write 0 here. Then coefficient of t to 4. Second equation, 2, 0, 0, and minus 4. Third equation will come 1, 1, 1, and 0. And while writing the fourth one equation, 1, minus 3, minus 1, and minus 10 is ratio lambda. Now we will reduce it to the row echelon form. Firstly, R2 changes to R2 minus 2 times of R1. R3 we will change R3 minus R1, and R4 minus R1. After applying this operation, we will get the following matrix. Here we will get 0, minus 2, 0, minus 6, minus 1, 0, 0, 1, minus 1, 0, minus 4, minus 1, and minus 11, lambda minus 4. Now we will apply R4 to R4 minus 2 times of R2. Now this will reduce to 1, 1, 0, 1, 0, minus 2, 0, minus 6, 0, 0, 1, minus 1, 0. This element will become 0. This is minus 1, and this is 1. Raised to lambda minus 2. Now R4 plus R3. We will get 1, 1, 0, 1, 0, minus 2, 0, minus 6, 0, 0, 1, minus 1, 0, 0, 0, and 0, and this will become lambda minus 1. Now let us consider the option number A. Option number A says that if lambda is equals to 1, then the system will have unique solution. Here, if you put lambda is equals to 1, rank of A will become 3. Rank of A augment will also become 3. Therefore, we will have the infinite many solution. So, option number A is incorrect. If you consider option number 2, if lambda is equals to 2, then it has infinite many solution. If you put here lambda is equals to 2, then here in this position we will get 1. Then the rank of A will 3 and rank of A augmented B is 4. Then we will have no solution. So option number B is also incorrect. If lambda is equals to 1, then it has infinite many solution. If you put lambda is equals to 1, then rank of A is 3. Rank of A augment B is also 3, and which is less than the number of unknown, that is 4. Here we can say that the system has the infinite solution. Now consider option number D. If lambda is equals to 2, then it has unique solution. Similarly, if you put lambda is equals to 2 here, rank of A is 3, rank of A augment B becomes 4. So it will have no solution. So option number 3 is the only correct option. So answer is option number C. Now we will discuss the relationship between the number of variables and the number of equation. Firstly, we will discuss the case of homogeneous system, that is Ax is equals to B, where B is non-zero. Let V denotes the number of variable and E denotes the number of equations. Let us say A be the matrix of order M cross N. Here we can say that M be the number of equation and N is the number of variable. First case is that if the number of variables is greater than the number of equation, that is N is strictly greater than M. Here from this case, if M is strictly less than N, then rank of A must be strictly less than N, because you know that rank of A is less than equals to minimum of Mn. Here we can say that if M is less than N, then rank of A is strictly less than N. Then the unique solution is not exist. But case of infinite and no solution may be exist. For this, let us take an example. X plus Y plus 2Z is equals to 1. And next equation is 2x minus y plus z is equals to 7. From here, you can see that by writing this in the augmented matrix, this system has the infinite many solution, because here rank of A is 2, rank of A augment B is 2, but the number of variable is less than is 3. Therefore, rank of A is equals to rank of A augment B is less than 3. Therefore, the infinite many solution. No solution is also possible. For this, let us take an example. X plus Y plus 2Z is equals to 1. And next one is 5x plus 5y plus 10z is equals to 6. After writing its augmented matrix, we will get this. Here you can see that rank of A is 1 and rank of A augmented B. After reducing it to the row echelon form, rank of A augmented B is 2. So rank of A is not equals to rank of A augmented B. Therefore, we will have no solution. Now the next case is if the number of variable is equals to the number of equation, then the system may have unique, infinite, and no solution. Here, let us take M is equals to N. That is the number of equations is equals to the number of variable. For unique solution, let us take a system X plus 2y is equals to 1, 2x plus 3y is equals to 4. You can easily see that rank of A is equals to rank of A augmented B is equals to number of variable. Therefore, this is the case of the unique solution. For infinite many solution, let us take another system. X plus 2y is equals to 1. What you will have to this 2 times of x, 4 times of y is equals to 2. After writing its augmented form, we will get this kind of matrix. Here you can see that rank of A becomes 1, rank of A augment B is also 1, which is less than the number of variables, that is 2. Therefore, this is the example of the system having infinite number of solution. If m is equals to n, then no solution is also exist. For this, let us take an example. X plus 2y is equals to 1, 2x plus 4y. What you will have to do is make the rank of A is 1 and rank of A augment B is always greater than rank of A. Then you will always get the no solution case. Here we will take 3. Here rank of A is 1. Okay. And rank of A augment B is 2. Therefore, this is the case of the no solution. Now, let us take the case number 3. If the number of variables is strictly less than the number of equations. If the number of variable, that is n, is less than m, that is the number of equation is greater than the number of variable. Here in this case, the system may have unique, infinite and no solution. For unique solution, let us take an example. X plus 2y is equals to 1. 2x plus 3y is equals to 4. And third one is 3x plus 5y is equals to 5. After writing this in the augmented form, we will get 1, 2, 1, 2, 3, 4, 3, 5 and 5. Here you can see that the number of variables are 2 and number of equations are 3. Here the rank of A is 2 and rank of A augmented B is also 2. Therefore, this is the case of the unique solution. For infinite solution, you can easily check by writing this system into the augmented matrix form. And third equation, you will take 3x plus 5y is equals to 6. For case of no solution, let us take another system. X plus 2y is equals to 1. 2x plus 4y is equals to 2. And third equation is 3x plus 6y is equals to 3. After writing this system into the augmented form, you can easily check that the following system will have infinite many solution and this system will have no solution. Now we will move towards the in case of the homogeneous system. In case of the homogeneous system, we will discuss the relationship between the number of variables and the number of equation. As you all know that if the system is a homogeneous, then the no solution case is not possible. Therefore, the solution is either of unique or of infinite. Firstly, A with the matrix of m cross n. First case is if the number of variables is greater than the number of equation. That is, number of variable here is n and number of equation here is m. If m is strictly less than n, you can easily check that rank of A is strictly less than n and this implies determinant of A is equals to 0. Therefore, the unique solution is not possible. Infinite solution may be exist. For this, let us write a system x plus y plus z is equals to 0 and 2x minus y plus 2z is equals to 0. After writing this system into the augmented form, we will get 2 minus 1 and 2. Rank of this system is 2, which is less than the number of variable, that is 3. Therefore, we will get the system is infinite solution. The next case is when number of variables is equals to the number of equation. Here the solution can be unique and infinite. For uniqueness, we will take a system that is x plus 2y is equals to 0 and 2x plus 4y is equals to 0. Here you can see that the number of equation is equals to the number of variable, that is 1, 2, 2 and 4. Here rank of this matrix is 1. Okay, the solution is infinite. If we talk about the unique solution, then let us take a system x plus 2y is equals to 0, 2x plus 3y is equals to 0. Here you can see 1, 2, 2 and 3 is the augmented form. Here the rank of this matrix is 2, which is equals to the number of variables. Therefore, the solution is infinite. Now, the third case is if the number of variable is less than the number of equation. For this, firstly, let us take a system x plus 2y is equals to 0, 2x plus 3y is equals to 0, 3x plus 5y is equals to 0. Here the number of variable is less than the number of equation. You can easily check that this system has a unique solution. And for infinite case, let us take an example. X plus 2y is equals to 0, 2x plus 4y is equals to 0, and third equation is 3x plus 6y is equals to 0. Here the rank of the augmented matrix will become 1, which is less than the number of variables. Therefore, we will get the infinite solution. Now, based on these results, we will discuss some questions. First question is a system of a homogeneous system of 5 linear equations in 6 variables admits no solution, unique solution, infinite many solution, or finite but more than 2 solution. Here you can see that the number of variables is 5, is 6, and the number of equations is 5. Here the number of variable is strictly greater than the number of equations. From here we can say that there are exist infinite many solution, because if you put in the matrix form we will get A be the matrix of 5 cross 6. Here the rank of the matrix is maximum 5. Therefore, the rank of matrix A is less than equal to 5, which is less than the number of variable 6. Therefore, rank of A is less than the number of variable. From here, we can say that there will exist infinite many solution. Now take another example, that is the set of equation x1 plus 2x2 plus x3 plus x4 is equals to 0, 3x1 plus 6x2 and 3x3 plus 12x4 is equal to 0. Now we will have to find whether this system will have a unique solution, no solution, unique non-trivial solution and multiple non-trivial solution. Here you can easily see that the number of equations are 2 and the number of variables here are 4. That is, the number of equations is less than the number of variables. From here we can conclude that this system will have a infinite many solution. You can also check this by writing its augmented matrix. Therefore, option number D is correct. Multiple non-trivial solution exist. Let us consider another question, that is, if P is a matrix of order 3 cross 3, then for some C, the linear system Px is equals to C has a infinite solution. Here the question says that Px is equal to C. For some values of C, this system will have infinite many solutions. Then we will have to check the first option. The linear system Px is equal to C has infinite solution for all C. Here B is not C. Second option is rank of P is equals to 3. Third option is rank of P is not equals to 1. And fourth option is rank of P is less than equal to 2. This system will have infinite many solution. It is given that. Therefore, rank of P is equals to rank of P augmented C is strictly less than 3. For case of infinite, we have this condition. This will imply rank of P is less than 3. Therefore, option number B is incorrect. Okay, from here we can say that rank of P is strictly less than equals to 2. Therefore, option number D become the correct option. Now, option number A says that the Px is equals to 3. C has infinite solution for all values of C. This option is incorrect. For this, let us take an example. X plus Y plus Z is equals to 1. 2x plus 2y plus 2z is equals to 3. And third equation, let us take 3x plus 3y plus 3z is equals to 3. The augmented matrix of this system will become 1, 1, 1, 2, 2, 2, 3, and then 3, 3, 3, 3. Here you can observe that the rank, after reducing it to the row echelon form, rank of this matrix is 1, and rank of, if you calculate rank of P augmented C is not equals to 1. For this, we will solve, say R2 to R2 minus 2 times of R1, R3 to R3 minus 3 times of R1. Here we will get 1, 1, 1, 2 minus 2, 0, 0, 0, 3 minus 2, which gives 1, and here 3, 0, 0, 0, and 0. Here you can see that the rank of the matrix is 1. Rank of P is 1, and rank of P augmented C becomes 2. Therefore, rank of P is not equals to rank of P augmented C, which is the case of the no solution. So option number A says that the solution is always infinite for all values of C. Therefore, this will become the incorrect option. Now, see option number C. Option number C says that rank of P cannot be equals to 1. If you take the similar example, here rank of P is 1, and option number C says that rank of P can never be equals to 1, which is also the incorrect option. Therefore, option number D is the only correct option out there. Now let us move to another question. Here, let m is strictly greater than 1 n is strictly greater than 1 and A be a matrix of order m cross n, such that for some m cross 1 vector b1, the system Ax is equals to b1 has infinite many solutions. Here you can see that Ax is equals to b1 has infinite many solutions. From here we can say that rank of A augmented v1 is equals to rank of A is strictly less than the number of variable, or we can say that the number of column here is n. This implies rank of A is strictly less than n. From the given condition, we can conclude that the rank of A is strictly less than n. Now, read again the question. Let B2 denotes an M cross 1 matrix that is different from the B1. And then we have to conclude Ax is equals to B2 has a unique solution, infinite solution, finitely many solution, or no solution for some values of B2. Here, for unique solution, we will have rank of A is equals to rank of A augmented B is equals to n. Now, from this condition, we can conclude it that rank of A is less than n. Here, for a unique solution, we must have rank of A is equals to n, which is not possible. Therefore, option number A is the incorrect option. Now, option number B says that the infinite many solution for some B2. For infinite many solution, we have the condition rank of A is equals to rank of A augmented B is strictly less than n. The rank of A is less than n, this condition is already satisfied. Now, infinite solution is exist. For this, let us take an example of system whose infinite solution is exists. That is, take the system x plus y is equals to 1, 2x plus 2y is equals to 2. The augmented matrix of this system is 1, 1, 1, 2, 2, 2. Here you can see that rank of A is strictly less than n, that is strictly less than 2. And after applying it to the row echelon form, we will get this matrix. Therefore, rank of A is equals to rank of A augmented B, which is less than 2. Now, this is the case of the infinite many solution. Now, by consider this system, if you take any example of the system, you must ensure that this condition, that is rank of A is less than n, is completely satisfied. If this condition is not satisfied, then you will not take that system as an example here. Therefore, option number B maybe is correct, because here it will write for some values of B2. Now, C is finitely many solution. This is incorrect. Now, the fourth one is the no solution. Now, for no solution, we will have, let us take an example of the system. No solution is always maybe exist. X plus y is equals to 1. Second equation is 2x plus 2y is equals to 3. After putting into the augmented form, we will get, here you can see that rank of the matrix A is 1 and rank of A augmented B is 2, which is the case which is not equal. And this is the case of the no solution. So option number D is correct. Now we will discuss the relationship about the homogeneous and the non-homogeneous system. Here, if the system Ax is equals to 0, case number 1 is if system Ax is equal to 0 has infinite many solutions, then Ax is equals to B has either no solution or infinite many solution. Here Ax, given that Ax is equal to 0 has infinite many solution. It is given that. From here, we can conclude it that rank of A is strictly less than the number of unknowns. That is strictly less than n. Now, let us take another system. Ax is equals to b, the corresponding non-homogeneous system. Here you can also say that the rank of A is strictly less than n. Therefore, the case of the unique solution is not exist, because the unique, in case of unique solution, we must have rank of A is equals to n. Therefore, unique solution is not possible. Okay. If you talk about the infinite many solution, for this let us take a system x plus 2y is equals to 1 and 2x plus 4y is equals to 2. After put into the augmented matrix, we will get, here you can see that the rank of A is 1 and rank of A augmented B. After reducing it to the row echelon form, it will also become 1, which is less than the number of variables, or we can say that the number of columns, that is 2. Here we can say that this is the example of the system which having infinite many solution. Now let us take another system of the no solution. For this, the example is x plus 2y is equals to 1, 2x plus 4y is equals to 3. The augmented matrix is 1, 2 and 1, 2, 4 and 3. Here you can see the rank of this matrix is 1. After reducing it to the row echelon form, we will see that the rank of A augmented B is 2. That is, the rank of A is not equals to rank of A augmented B. Therefore, solution, there does not exist any solution. Now we will discuss the case number 2. The case number 2 says that Ax is equals to 0 has a unique solution. If the solution is unique, then rank of A is equals to n. That is the number of the variable, or we can say that the number of the columns. From here, we will have to talk about the system of non-homogeneous. Then this system will either have unique solution or no solution. Here you can say that rank of A is n. If rank of A is n, then the case of infinite solution does not possible, because in case of infinite many solution, rank of A is equals to rank of A augment B must be less than n. Here we can conclude it that rank of A is less than is equals to n. Therefore, the case of infinite many is not possible. Now, for the unique solution, let us take a system that is x plus 2y is equals to 1 and 2x plus 3y is equals to 4. Here you can easily see that if you take the right side 0, then the matrix will become 1, 2, 2 and 3. Now the rank of this matrix is 2. That is the system corresponding homogeneous system have a unique solution. Now we will have to talk about the non-homogeneous system, that is 1 and 4. Here the rank of the matrix A is 2 and rank of A augmented B is also 2. Therefore, this is the case of the unique solution. Now for the no solution, let us take an example. X plus 2y is equals to 1, 2x plus 3y is equals to 4, and 3x plus 5y is equals to 6. After writing this system into the augmented matrix, we can see that 1, 2, 1, 2, 3, 4, 3, 5, and 6. You will have to perform to row echelon form, that is R2 to R2 minus 2 R1 and R3 to R3 minus 3 R1. 1, 2, 1, 2 minus 2 is 0 and 3 minus 4 is minus 1. 4 minus 2 will become 2. 3 minus 3 is 0. 5 minus 6 is minus 1 and 6 minus 3 is 3. Here you can see that the rank after applying R3 to R3 minus R2, we will get 1, 2, 1, 0, minus 1, 2, 0, 0, and 1. Here you can see that the rank of the matrix A is 2 and rank of matrix A augmented B is 3. Now this is the case of the no solution. Now we will discuss the relationship between homogeneous and non-homogeneous. If we have given a system of non-homogeneous, now what will be the system of the homogeneous? If AX, for case number 3, if AX is equals to B has a unique solution. If has a unique solution, from here we can say that the rank of A is equals to rank of A augmented B is equals to the number of column, that is the number of the variable. Here we can conclude that the rank of A is equals to N. Now the corresponding homogeneous system AX is equals to 0. From here we can easily say that the rank of A is N. That is, the system AX is equal to 0 will have a unique solution. Now take case number 4. If AX is equals to B has infinite many solution. If AX is equals to B has infinite many solution. If this system has infinite many solution, then we have the following condition. Rank of A is equals to rank of A augmented B must be less than N. Here we concluded that the rank of A is strictly less than N. Now for corresponding homogeneous system, rank of A is strictly less than N. Therefore, this system will have a infinite many solution. Now case number 5 says that if AX is equals to B has a no solution, then AX is equal to 0 has either unique solution or infinite many solution. For uniqueness, let us take an example. X plus 2y is equals to 1. 2x plus 3y is equals to 4 and 3x plus 5y is equals to 6. Here you can easily verify that 1, 2, 1, 2, 3, 4, 3, 5, and 6. After reducing it to the row echelon form, you can easily see that this system will have a no solution. Now the corresponding homogeneous system will become 1, 2, 2, 3, 3, and 5. Here the rank of the matrix A becomes 2, which is equal to the number of variables. That is, from here, this case will have a unique solution. Now for case of infinite many solutions, let us take an example. X plus 2y is equals to 1. 2x plus 4y is equals to 3. Here you can see that the rank of the matrix A is 1 and the rank of matrix of A augmented B is 2. This is the case of the no solution. Now the corresponding homogeneous system will become this matrix. This here rank of A is equals to 1, which is less than the number of column. This is the case of the infinite many solution. Now the case of no solution is not possible. How can we say that the case of no solution here is not possible? For this, given that Ax is equals to B has no solution. Here we can easily see that the rank of A is not equals to rank of A augmented B. That is, the system will not have the no solution. You can hear this condition given that the system will have no solution. Therefore, the corresponding system Ax is equal to 0. As you already know that the system of homogeneous is consistent always. Therefore, this system will not have a case of the no solution. Now, based on these results, we will discuss the another question. Another question says that consider the non-homogeneous system of linear equation Ax is equals to B, where A be the matrix of order M cross N. The first condition says that the corresponding homogeneous system Ax is equal to 0 has a unique solution, implies Ax is equals to B has infinite solution for each values of B. Here given that the system, homogeneous system has unique solution. Now then the corresponding non-homogeneous system will have always have an infinite solution for any values of B. Here you can see from case number 2, we have discussed here. The system will have infinite. Case number 2. Here the system is has unique solution. Therefore, the corresponding non-homogeneous system will either have unique or no solution. Here the option says that if the system will have unique solution, then the corresponding non-homogeneous system will have infinite many solution, which is wrong in this case. By consider the case number 2 we have discussed above. Now consider the next statement. If the corresponding homogeneous system has a non-zero solution, therefore rank of A is strictly less than n, then there exists a vector B in Rm for which this has a no solution. You can see from case number 1, if system has infinite many solutions, then the solution can be no or infinite. Here option number D is correct. Because there is existence. Here we can say that option number 1 is false and option number 2 is correct. That is option number C is correct here. Now let us take another question. Let us suppose alpha, beta and gamma belongs to R. Now consider the following system. Now the augmented matrix of this system is 1, beta, gamma, 1, 1, alpha, beta. Firstly, we will do R2 minus R1. Then 1, 1, 1, alpha, it will become 0. This element become beta minus 1, this will become 0 and this will become gamma minus alpha. Now R3 minus R1, 0, 0, alpha minus 1 and beta minus alpha. Now let us consider the option number A. Option number A says that if alpha is equals to 1, then this implies gamma is equals to 1. If you put alpha is equals to 1 there, and we will get the system 1, 1, 1, 0, beta minus 1, 0, and gamma minus 1, 0, 0, 1 minus 1. This element will become 0 and this will become beta minus 1. Now given that alpha is equals to 1, then this will implies gamma is equals to 1. here alpha is equals to 1, and also it is given that the system will always have at least one solution, which means system is consistent. Now for consistency, we always have rank of A is equals to rank of A augmented B. Here you can see that the rank of the matrix A for beta is not equals to 1, the rank of matrix A is 2. And here, if beta is not equals to 1, let us take beta is equals to 2. Here we can say that for consistency, for consistency, we have rank of A is equals to rank of A augmented B. Now for system this to be consistent, we must have beta minus 1 is equals to 0. That is, beta must be equals to 1. From here, we can see beta is equals to 1. After putting beta is equals to 1 into the system, we will get 1, 1, 1, 1, 0, 0, 0, gamma minus 1, 0, 0, 0, and here 0. Now for this system to be consistent, we must have gamma minus 1 is equals to 0. That is, gamma must be equals to 1. Therefore, option number A is correct. Here we will do that. What we will do here firstly we will reduce the system into the row echelon form. Now given that system has at least one solution, therefore rank of A must be equal to rank of A augmented B. Now for this system has a solution, this element must be equal to 0. For rank of A is equal to rank of A augmented B. Therefore, beta minus 1 is equals to 0. That is, beta is equals to 1. Now, for beta is equals to 1, what we will do? We will put beta is equals to 1 in this system. Then this system will reduce to 1, 1, 1, 1, 0, 0, 0, gamma minus 1, and this. Now, this is for this system to be consistent, we must have gamma minus 1 is equal to 0. That is, we get gamma is equals to 1. We can say that the option number A is the correct option out there. Now, let us consider the another option. Option number B. Now, option number B says that if beta is equals to 1, this will imply gamma is equals to alpha. Let us put beta is equals to 1 on the system above. We will get 1, 1, 1 raised to 1, 0, 0, 0, gamma minus 1 sec. System is this 1, 1, 1. Given that beta is equals to 1, then the system is 1, 1, 1, and here 1, there is alpha. And we will have to put beta is equals to 1. Therefore, beta is equals to 1. Then we will get 0, 0, 0, and gamma minus alpha. And the third row becomes 0, 0, and alpha minus 1 and 1 minus alpha. 0, 0, alpha minus 1 and 1 minus alpha. Now, for this system to be consistent, we must have gamma is equals to alpha. Therefore, option number B is also the correct option. Now we will discuss option number C and option number D. For option number C, let us take beta is not equals to 1. Then we will have to check if beta is not equals to 1, then alpha is 1 or not. For this, let us take an example. Say alpha is equals to 2. Let us take alpha is equals to 2, beta is equals to 2, because we have to take beta is not equals to 1, and gamma is equals to 1. Therefore, the above system reduces to 1, 1, 1. Alpha is equals to 2, therefore 2. 0, beta is equals to 2. 1, 0, and gamma minus alpha, that is minus 1. And the third row becomes 0, 0. Alpha minus 1, that is 1, and beta minus alpha, that is 0. Here you can see that this rank of the matrix A is 3 and the rank of A augmented B is also 3. This system is always have a unique solution. Therefore, what this option becomes the incorrect option, because the option says that if beta is not equals to 1, then alpha must be equals to 1. Here we have taken that beta is equals to 2 and alpha is equals to 2. We get a system of linear equation which will admit a unique solution. Therefore, option number 3 is the incorrect option. Now, for option number D, if gamma, option number D says that if gamma is equals to 1, then this will imply alpha is equals to 1. From the same example, you can take gamma is equals to 1, alpha is equals to 2, and beta is equals to 2. This will reduce to this system. From here, we can see that if gamma is equals to 1 and alpha, from here, alpha is not equals to 1. That is, alpha is equals to 2. That is, option number D is also the incorrect option. Because we have find such a system where gamma is equals to 1 and alpha is not equals to 1. From here we can say that option number A and option number B is the only correct option. Now we will discuss about the nullity and rank nullity theorem. Before defining nullity, firstly we will discuss what is null space. Let A be a matrix of order m cross n, then the null space of the matrix A is the set of all n-dimensional column vectors such that Ax is equals to 0. Or we can say that the null space of A is the solution set of the linear homogeneous equation. That is, Ax is equal to 0 is the linear homogeneous equation. Then the collection of the solution set of this system is the null space of the matrix A. Now, nullity of the matrix. The dimension of the null space of the matrix A is the nullity of the matrix. That is, we can say that the dimension of the solution space of this linear system of homogeneous equation is known as nullity of the matrix. Let us take an example. A is equals to 1, 1, 4, 5, 2, 3, 4, 5. Firstly, we will convert A into the row echelon form. Then we will get this matrix. After applying it to the row reduced echelon form, we will reduce to the this matrix. Now for solution set Ax is equals to 0, we must have x1 minus x3 minus 2x4 is equal to 0. That is x1 here, the matrix is after writing this into the system, we will have x1 minus x3 minus 2x4 is equal to 0, x2 plus 2x3 plus 3x4 is equals to 0. If you know the values of x3 and x4, you can easily calculate the values of x1 and x2. Therefore, from here, we can see that the dimension of the solution space is 2. Therefore, the nullity of the matrix A is 2. If you know the value of x3 and x4, you can easily calculate the value of x1 and x2. Therefore, the dimension of null space becomes 2 and nullity of A becomes 2. That is the dimension of the solution space. Now we will discuss the rank nullity theorem. The rank nullity theorem. What this theorem suggests that the sum of the rank plus nullity of the matrix A is equals to the number of columns. This theorem will also known as the Sylvester law. Here, by solving the previous question with the help of this theorem, we can easily see here the rank of this matrix is 2. Now, by knowing this theorem, we can write rank of A plus nullity of A is equals to the number of column, that is 4. Here rank of A is 2 plus nullity of A is 4. That is nullity of A will become 4 minus 2, that is 2. We can also solve the above question by using this theorem. Now we will discuss some more question about the nullities. Question says that if the nullity of this matrix is 1, then we will have to calculate the value of A. Given that we know that rank of A plus nullity of A is equal to the number of column. Here the number of column is 3. Given that the nullity of A is 1. Therefore, the rank of A must be less than 3. That is, the rank of A from here is 2. By putting the nullity is 1 here, we can conclude it that the rank of A is equals to 2. That is, from here, this implies the determinant of the matrix A is 0. Now we will calculate the determinant of the matrix K1, 2, 1, minus 1, minus 2, 1, 1 and 4. Here, by finding the determinant, we will get K minus 4 plus 2 minus 1, 4 plus 2 plus 2, 1 plus 1 is equals to 0. That is minus 2k minus 6 plus 4 is equals to 0. That is minus 2k minus 2 is equals to 0. Minus 2k is equals to 2 and k is equals to minus 1. Therefore, option number A is the correct option. Now let us take another question. Here A is given to the matrix of order n cross n with real entries such that A square is equals to A. That means the matrix is idempotent. We have given that rank of A minus I is equals to M. We have to calculate the nullity of the matrix A. Here, given that the matrix is idempotent and we have a result. If the matrix is idempotent, then rank of the matrix A is equals to the trace of A. And if the matrix A is idempotent, we have I minus A is also idempotent. Therefore, the rank of I minus A is equals to the trace of the matrix I minus A. Now, using these results, we will calculate the nullity of the A. By the rank nullity theorem, we know that the rank of A plus nullity of A is equal to the number of column, that is n. Here, nullity of A will become n minus rank of A. Now, we can write n is equals to trace of the identity matrix of order n cross n. We can easily write n to the trace of identity matrix of order n cross n. And we know that rank of A is equals to trace of A. That is, from here, we can say that rank of A is equals to trace of. We know that trace is a linear property. That is, trace of A plus B is equals to trace of A plus trace of B. That is trace of I minus trace of A is equals to trace of I minus A. Now using this result, we can say that trace of I minus A is equals to rank of I minus A. By using this result, we can write trace of I minus A is equals to rank of I minus A. And it is given that rank of A minus I is equals to M. If rank of A minus I is equals to M, then rank of I minus A will also equals to M. Now from here, we will get nullity of A is equals to M. Therefore, option number B is the correct option. Now let us take another example. Let A be the matrix and then we have to choose the correct option out there. Rank of A is equals to nullity of A is equals to 2. Rank of A is 1, nullity of A is 2. Rank of A 2, nullity of A 1 and none of this. After reducing it to the row echelon form, we can easily see that the rank of the matrix A is 2 and the nullity of A. We know that rank plus nullity is equal to the number of column. Here number of column is 3. We have rank of A is 2. Therefore, nullity of A will become 1. Therefore, option number C is the correct option. Now, question number 14. Let A be the matrix of order n cross n such that Aij is equals to 3 for all values of I and j. Therefore, the matrix becomes 3, 3, 3 up to so on, 3, 3, 3, so on, and 3, 3, 3 of order n cross n. After applying R2 to R2 minus R1, R3 to R3 minus R1, and so on, Rn to Rn minus R1, we will get 3, 3, 3, and 0. All other rows becomes 0. Here you can see that the rank of the matrix A become 1, and from the rank nullity theorem, the nullity of A will become n minus 1. So option number A is the correct option. Now the invertibility condition of the matrix A. For the matrix A of order m cross m, firstly you must ensure that the matrix must be square. A be a matrix of order m cross n. Now for A to be invertible, we must have determinant of the matrix A is not equals to 0. Now let us take the last question. Let A be the matrix of order m cross n. Now let us consider the following statement. First statement says that given that A be the matrix of order m cross n. First case says that if rank of A is m, then A is invertible. Given that if rank of A is m, what if m is not equals to n? Let us take a case. A be a matrix of order 2 cross 3. Here m is not equals to 3. And let us take the matrix A in such a way, then rank of A becomes 2. Here the matrix A is not invertible. Therefore, option number first is the incorrect option. Now, from the similar point of view, you can easily discard the option number 2. Option number 2 says that if rank of A is n, then A is invertible. Let us take the matrix A to be 3 cross 2 and choose matrix A in such a way the rank of A becomes n, that is 2. Here the matrix is also not invertible because matrix is not a square matrix. Now third option says that. So option number B is also incorrect. Now option number third says that if A is invertible, then nullity of A is 0. Given that A is invertible, if the matrix A is invertible, then matrix must be square. Therefore, this implies M is must be equal to N. And if matrix is invertible, then we have determinant of A is non-zero. That is, rank of A must be equals to M and must be equals to N. Therefore, the rank of A is equals to N. If rank of A is N, then from the rank nullity theorem, you can easily see that the nullity of A is 0. So option number 3 is the correct option. If you talk about the option number 4, if nullity of A is non-zero, then A is invertible. Given that nullity is non-zero, let us take a matrix A to be the order 2 cross 3. If nullity and rank of A to be 2, nullity of A will become non-zero. Here, by choosing this type of matrix which satisfies nullity of A is non-zero, this matrix is not an invertible matrix. Therefore, option number D is also the incorrect option. Now move towards the option number 5th, statement number 5th. If nullity of A is 0, then A is invertible. This is also the incorrect option. For this, let A to be the matrix of order 3 cross 2 and rank of A is 2. Here you can see that rank of A is 2. This will imply nullity of A is 0. That is, nullity of A is 0, but A is not invertible because A is not a square matrix. So option number 5th is also the incorrect option. Now we will discuss about option number 6, option number 7 and option number 8. For option number 6, if A is invertible, then rank of A is N. Given that A is invertible. If A is invertible, this will imply M is equals to N and determinant of A is non-zero. And if determinant of A is non-zero, then rank of A is equals to N. Therefore, option number 6 is the correct option. If we talk about option number 7, if A is invertible, then M is equals to N, which is also a correct option. And option number 8 is incorrect. It is from here given that if M is equals to N, then A is invertible. No, you can take 1, 1, 1, 1. Here, M is equals to N, that is 2 is equals M is equals to N is equals to 2, but the matrix A is not invertible. From here, we can see that only statement number 3, statement number 6, and statement number 7 is correct. Therefore, option number E is the correct option. If you have any query, you can ask.
Okay, students, you can express your comments.
Hi, ma'am.
Yes, Dina.
Hello, Dina.
I am Dina K from Government Victoria College, Palakkad. Ma'am, first of all, I would like to thank Vinod sir for all these sessions. Thank you, sir, for pushing me up even in my lowest peak. Thank you so much, sir, for keeping all of us in track. Thank you. And ma'am, we are really pleased to get such a wonderful class. We really hope that we get more classes from you, ma'am. Thank you.
Yes, sir. Yes, sure.
Hello.
Yes, Nishita.
Hello, ma'am. Hello, sir. Thank you
Hello,
for taking
Nishita.
this interactive session. And thank you, sir, for this session. Thank you.
Thank you, Nishita. Others?
Hello, ma'am.
Yes, Gayatri.
Hello.
I'm Gayatri. I have studied in Miranda House College, Delhi. The class was very nice and you have explained everything so well. And I hope we'll get more classes from you, ma'am. Thank you. Thank you, sir.
It's my pleasure.
Thank you, Gayatri.
Hi, ma'am. Today's class was really so nice. Today you have discussed so many problems and that was really helpful for us. And thank you, ma'am, for your effort. And thank you, Vinod sir, for organizing the session.
Thank you, Nandini.
You're most welcome.
Yes, others.
Hi, ma'am. My name is Harita. I'm from Matoma College, Sumatra. Thank you so much for a wonderful session. It was a very long and detailed session. I've asked a variety of questions. Thank you so much, ma'am. Thank you, sir.
Thank you, Harita.
Good afternoon, ma'am, and good afternoon, sir. I am Adra Sandosh from Government Victoria College. And ma'am, today's class was really nice and it was very helpful to understand. And today you have discussed a lot of variety questions and it helped us to score good marks in this topic, because in our colleges only our teachers has taken a particular that what I say only just as simple notes, and they have only given for our to score good marks in our university papers. So today's sections was really nice, and thank you, ma'am, and thank you, sir, for arranging such a wonderful class for us. Thank you.
Thank you, Adra.
Hello, ma'am.
Yes.
My name is 𝐒𝐲𝐬𝐬 and I'm from Ernakulam St. Teresa's College. The session was very interesting and it was very helpful for us. Thank you, ma'am. Thank you, sir.
Yes, thank you, Srinivas.
I am Dharmendra Singh from Kashgan, UP, and presently working in BARC Vizag campus in library. Session was very niceful and very good. Please, can you share some reference books that used by you, and can you share your experience about PhD journey?
Can you please repeat your question?
Can you tell some reference books, and can you share your PhD experience also?
Sorry.
See, Rupali, he is asking about some reference books for preparing these ideas, as well as about your PhD admission, PhD interviews, and all that. Okay.
Oh, okay, fine. Firstly, the basic book is the 𝐂𝐲𝐬𝐿 series. You can start with the 𝐂𝐲𝐬𝐿 series edition. Then you can go to the Hoffman and Kunz and the Fredberg book. These all are the best book, and I also read these books. And if I talk about my PhD experience, I did my M.Sc in 2020, and on the same year I got admitted in the PhD course, and it was unbelievable to crack the PhD entrance exam, because at that time I didn't have any net exam. I didn't qualify any net or any JRF or any GATE exam. I only qualified the entrance exam of the university, and on the basis of that entrance exam, I got admitted in the university for the PhD program. Yes, PhD. My PhD topic is very interesting, and my PhD is going very well. I am really enjoying my PhD.
Thanks, ma'am.
Thank you, Dharmendra. Any others?
Hello, sir.
Yes, Gopika.
Hi, ma'am. I'm Gopika, third year B.Sc Maths student from Xamaurians College, Kerala. It's really nice session, ma'am. Thank you so much for taking this nice session. You explained everything with along with the examples, so it's really helpful for understanding us easily. Thank you so much, ma'am, and thank you, Vinod sir, for conducting this session. Thank you.
Thank you, Gopika.
Hi, ma'am. I'm Amrita from Srishnaram VTB College. It was a really wonderful and well explained session. Thank you, ma'am, for your spending your valuable time for us. And thank you, Vinod sir, for organizing such a wonderful session. Thank you.
Thank you, Amrita. Yes,
Hello.
Anamika.
From 𝐒𝐲𝐬𝐭𝐞𝐦𝐬 College from Kozhikode, Kerala. Ma'am, very nice session, ma'am, and the selected questions was really nice. Thank you, ma'am, for this session, and thank you also for these classes. And we expect many more classes from you, ma'am. Thank you, ma'am.
Thank you.
You're most
Thank you,
welcome.
Anamika.
Hi, ma'am.
Rupa, yeah.
And this is very nice. You explained on all solving questions very well. It is very helpful to use. Thank you, sir, for conducting this session. Thank you.
Thank you, Sakran. So, Rupali, could you explain some tips to the students for their examination? They have many doubts in their preparations because
So your
along with
voice is
the
breaking. I can't hear you. Please, can you repeat? Your voice is breaking.
okay. Is it audible now?
Yes, sir. Yes, sir. Now it's audible.
Okay, I am asking that many of our students facing many difficulty in preparations because of they have hectic portions to cover for their college semesters, and they don't know how to manage the time effectively for both preparations for college as well as for the JAM examination. So I think you can share some tips to them in their preparations.
Okay, sir. The first, if you want to qualify any exam, whether it's your college level exam or it's national level or any other exam like IIT, JAM, GATE, CSIR, NET, the first thing is you have to be consistent. Consistency is must. If you are not consistent, if you are not working the day in daily routine, you will suffer many problems. The next is the hard work. If hard work and consistent both comes, then it is a perfect match. Then with these kind of qualities, you can qualify any exams. If many students have doubt, I don't have time, I don't have such time to do such kind of things. You have time, you have enough time. You have to look upon this. You have 1 hour now. If you can do that kind of stuff in 45 minutes, you can do it now. Why you will do it tomorrow? Why you will take it to tomorrow? So that if you will do that work now, you will have next work to come in the tomorrow day. So first is consistency, hard work, and most important, the smart work. And if you have all these things, you can qualify any exam, literally any exam, whether it is TIFR, IIT JAM, CSIR NET, or any difficult level exam.
Thank you, Rupali. Thank you for being with us. And your words are really inspiring for our students. And the session done on the systems of linear equations is a very helpful for them in their preparations for JAM examination, because from this area there are lots of problems for JAM examination. So once again, I would like to express my sincere thanks and gratitude to you for being with us, and we expect more sessions from you for our students, so we can plan about it in future.
Yes, for
Okay.
sure.
Yeah.
I will love.
Thank you. So let us wind up here. Thank you, everyone. Bye.
Thank you so much.